Hey, astronomy. So chapter 4 is a challenge, but it's fun. I think any challenge that you struggle with, grind out and meet and get, once you get it, you go, wow, that's really cool. I did something special. We're going to talk about the Earth-Moon dance, or you could say the Earth, Moon, and Sun dance. The heliocentric truth we know now, thank you, Brahe, Kepler, Galileo, Newton, and those before and those not mentioned all around the globe. We know that it's heliocentric, there's no question. Sun-centered, not quite at the center, right? Because it's elliptical, but it's very close to circular path, so that's fine. But it reveals what's really going on. What makes it so that we see what we've seen for thousands of years, but didn't quite know why. And so connecting those two is where we're going here. And let me just start you off here. And sorry, I'm going to do this. Let's come over here and see what the challenge is. So we've got seen from Earth, your sky, and we're going to try to connect that to seen from space or a spaceship and what's really going on. So seen from Earth, we know that we step outside and there's our ground. And we've got these cardinal point directions, north, east, south, west, and we look up. So we're standing there on the green grass. It's easier to draw this if we just flatten that circle of our horizon out and we say eat sandwich. We know things, everything. Sun during the day rises and then is out during the day and then sets. Somewhere around east, stars rise around east and set in the west. Moon rises in the east and sets in the west. Planets move, arise in the east and set in the west. You see that line from south would go up and over to north. What's that called? That's right, the meridian. And to watch sun, moon, and planets from the northern hemisphere, we would face south. Sun would be before the meridian, that orange line, antes meridian, before the meridian, ante meridian, in the morning, and then it would hit the meridian about noon, leaving out complications of daylight saving time, etc. And then after noon, past the meridian, PM, post-meridian, past meridian, it would be there. And then we know too that we've seen for thousands of years that sun would not be seen if you're facing north, it would be at your back. Now you've turned around, so what was on your right, namely west, is now on your left. Still, things rise roughly in the east, somewhere there. However, things would look different. At nighttime, you would see stars rise up and go around that one dot star there. It's not too bright, it's a magnitude 2, and that, of course, is Polaris, or the North Star, the guiding star for your navigation if you haven't got GPS or a compass. We see the stars rise somewhere in the east. They circle around Polaris and they set somewhere in the west. However, some never set. They're out day and night. And those are circle around Polaris or circumpolar. Okay, so we know we've seen that. And in chapter 1, we talked about all the things we could see, or at least a good number of things. In chapter 4, now we're going to look at what's really going on so that we see this. Now we've got 2 points of view. One is a side view of Earth. Now notice that you're not looking from Earth. Earth is way out there. You've got to get a text message from your friends on Earth to see what they're seeing. You are an alien, right? And so this point of view, the side view, notice the North Pole is there at the top. I've tilted it because we're going to use that to show the seasons, a side view of Earth. It's a little hard to show the moon phases and the moon orbit. As you notice, I've kind of drawn that black line connecting moon. You can tell which is moon, right? I've drawn moon at one position, and then about how long after? About 2 weeks, halfway around, right? About. Sun is, of course, 1 AU away, about 93 million miles away. So I've just drawn the sunlight, rays of light, orange coming in from the right there. Anyway, that's a side view. A top view makes it easier to watch moon orbit Earth. You see, if I change the viewpoint from a side view where North Pole is there and South Pole, you see that, and I've shown the tilt. Here on a top view, I'm not worrying about the tilt, and you've got North Pole right there in the center. You're looking down on that dot. Notice here also you can see the phases. Whatever side is facing sun is lit, and whatever side is facing Earth is what Earthlings see. Here too, whatever side is facing sun is lit, and whatever side is facing Earth is what we see. In fact, look at Earth. Folks on Earth can spin into the light at, oops, I wrote sunset, didn't I? Who caught that? We see what that is. That's wrong. Sunrise. Noticed that people would spin into the light at sunrise and spin around out of the light at sunset, crossing the terminator, sunrise, sunset. Don't worry about moon spin till the end of the chapter. Okay, so we've got to connect. Why do we see what we see? Because something's going on. And we're going to check that out now. So I'm going to come here and take a look. Here we are with our sheep, ancient shepherds, eat sandwich, looking up, wondering why we see what we see. Who would think that we're on a globe floating in space, spinning? It certainly doesn't feel as though we're spinning. It doesn't feel as though we're moving. It feels like we're just standing on solid, non-moving ground. Okay? So it's reasonable to think that that's the way it is, just flat Earth, standing on solid ground. In fact, we're spinning, and as you know, around mid-latitude, say San Francisco, you're going at about 700 miles an hour, about the speed of sound. Spinning once every 24 hours. Now notice that the circle of the equator is a larger circle, and they spin at a speed of about 1,000 miles an hour, and still making one circle in 24 hours. So who would know that that's what's happening here? Pretty cool, right? We're just looking up. We've been looking up for thousands of years. We want to know what's going on. So we're going to use models, and we're going to imagine what could be going on as seen from space. So seen from Earth, Earthlings, seen from space. When you're looking from space, if you want to know what Earthlings are seeing, she's going to have to text you a text message to see what she's seeing and connect that with what you're seeing. So that is our challenge. And up next, we're going to have two meanings for year, day, and moon cycle.